I would just have one slide quickly on semiconductors. I think we all know this is a bit of a niche area in Australia, but I just would like to drop a couple of words about that. This is all about managing the complexity of the newer 7 nanometers designs. And the chips come with a 70% area reduction, and compared to the 60 nanometer FinFET technology, but we are maintaining the same amount of transistors. So it's getting a lot more complex in this little area, and that is important. The power consumption drops by about 60%, and that makes the technology so important for mobile platform, but also for automotive platforms. Power integrity is very important here. It's basically the second step after we are looking at the power management itself and the loss reduction. Loss reduction can be done by basically by changing or switching functional blocks on and off during the operation. So if you need one app, one functional block is switched on. If you need another app, this one is switched off and then the other one goes on. But what we have here is we have surges on our power supply during that switching, and also noise, and that needs to be analyzed. And we have dedicated tools for chip level analysis for that. One important fact is, or point is, the reliability on that. I would just like to mention two aspects. The first is electromigration, where we have movement of metal ions that create voids and also hillocks in traces in wires. We can do a full chip analysis on those for those applications, and then test it based on current direction, also on temperature, and make a call on where we have electromigration on our chip. The second is ESD, for example, electrostatic, that is electrostatic discharge, where we have a charge or transfer of charge from an IC or to an IC that can cause catastrophic failure, for example, in gate oxides or metal or wires. So example, what we can do here is ESD discharge pathways analysis and so on. A topic which is, I think, a lot more relevant on that perspective is the PCB or the board level power integrity. And what we can do here is we can combine actually the model of the chip with your PCB together. So how does it work is that the ANSYS Red Hawk tool generates a chip power model. That's a little SPICE format type of component. And that keeps all the impedances and all the parasitics of that chip, and also the current switching profiles. And you can directly bring that into your PCB and analyze the entire board level power integrity with the accurate chip model.